Okay, so this is exam 1, question number 3. A 2 kilogram mass held at rest on a smooth table, therefore there's no friction. Masses 4 and mass 1 are attached to the 2 kilogram mass by lighting extendable strings which pass over a smooth pulley. Okay, so this is what we have happening. This 2 kilogram mass is sitting on the table, so it will have a weight force of 2g. This 1 kilogram mass will have a weight force of g, and this 4 kilogram mass will have a weight force of 4g. Coming off the 4g is a T1 tension, and that's connected to have a T1 tension. This will be T2, and this here is T2. The only other force I've got is a normal reactive force pushing the table back up on this force. Okay, so they're the only things that I've got happening. So if I wish to find the acceleration, what I'd like to do is to treat it as a whole system. Since this is 4 kilograms and this is 1 kilogram, I think this system is going to move in this direction. So I'm going to know a resultant force in the direction of motion will be any forces going in the direction of motion. And the forces going in the direction of motion is 4g, T1 and T2. So I've got 4g plus T2 plus T1. They're all going in the direction of motion. And the forces in the opposite direction are T1, T2 and G. Minus T2, minus T1, minus G. I replace my resultant force with MA. M will be the combined whole system. So 4 plus 2 plus 1 gives 7A equals 3G. Therefore, A equals 7G on 3. And the direction of motion is to the left. So that's part A. Part B says, find the ratio of T2 over T1. Because the whole system, my T's cancelled themselves, I need to look at things separately. So I've initially done the 4 kilogram mass by itself. So that's the one that's hanging. That's 4G, that's T1. So I'm saying the resultant force in the direction of motion, which is going down, is going to be 4G minus T1. I replace the force with mass times acceleration. My mass is 4, that's my acceleration, rearranged for T1, I get 16G on 7. Then I looked at the 1 kilogram mass sitting in isolation, and I've got the resultant force which is going up is T2 minus 1G. Replace mass with mass times replace the R with mass times acceleration, I get this. Then I can get a fraction for T1 on T2, it's 8 on 5. I happen to choose these two. I could have easily have chosen the middle one, but I avoided choosing the middle one because in the middle one I will have T1 and T2 involved, whereas this one I just have T1 and I can solve for it, and this one I just have T2 and I can solve for it, but I could easily have done a substitution.